So the paper I wrote is with my friend Krishna. Krishna is an empirical economist. He does very high-class estimation of demand systems, and I'm going to talk about that a little bit. I always feel, I'm a theorist, right? So I always feel inadequate about empirical issues. And so I've written a bunch of papers with Krishna where he does the empirical side and I do the theory. So I'm going to talk about that a bit. So anyway, that's the table of contents. I'm going to talk about the critical level generalized utilitarian family, which I've been defending for 30 years. Talk about interpersonal comparisons of utilities and one way to make them. And some weird theoretical considerations, including how we torture mice to get monoclonal antibodies. And I'm going to make a couple of comments on whether there are too many people alive right now. Now, this is what the critical level utilitarian family looks like. X with a comma, Y are alternative histories of the universe. So those are the things I'm trying to rank according to their goodness. And critical level utilitarianism ranks X is at least as good as Y if and only if. And this formula says, in X, take every single person's utility of the people who ever live in X and subtract some number alpha from them and add them all up. And that's what both sides say, and Y do the same thing. Alpha is a parameter. That is, there's a different principle at issue for every single value of alpha, which can be, in principle, negative, positive, anything. Down below it explains it. N of X, N of Y are the people who ever live in X or Y. UIX, UIY are their utility levels. If a person I have here, she ever lives in X or Y. You can tell I'm going blind. I can't tell the difference in periods and commas anymore. Individual utilities are indexes of lifetime well-being. Now, Theron gave you a little homily about that this morning, and I'm just going to leave it at that. It should be lifetime well-being because if people's lifetime changes in different histories, then you don't want to be mistaking that for a population change. Alpha is the critical level, at least that's what we call it. Additions to a utility unaffected population, add one more person, no one is affected except that person now exists. If that person is above alpha in his or her utility, it's good. If below, it's bad. At alpha, it doesn't matter. Now, in my formula, it's if and only if above, so that means that strict betterness, is a strict inequality, and equality means they're equally good. CLU is a different principle for each value of the critical level. The CLU value can be written differently. You can write it as population size times average utility minus alpha. So you can see that from the formula here. If you add them all up, you do it population size times. And so on the left, you've got average utility. In the first term, you've got average utility multiplied by the population size. And that's the sum of utilities. And the second term is population size times alpha. And so you can rewrite that as population size multiplied by average utility less alpha. CLU has a really interesting advantage that I'm going to talk a bit about. It doesn't require knowledge of either the existence or the utility levels of people whose lives are over in all feasible alternatives. Now, that is a really great thing to have if you're doing applications of this stuff. We don't know very much about how well off Cleopatra was, or Socrates, or all those guys, or how many of them there were. We don't even know if there's a humanity salted away on some distant planet that we don't know about. And we don't need to know if we use a principle like this. CLU with a positive critical level avoids Parfit's repugnant conclusion. Parfit's repugnant conclusion says it's a bad thing if numbers can always substitute ethically for average utility. So you can drive average utility down as low as you want to, above zero. And if you have a high enough population size, that can be better. And that won't happen unless, except above alpha. So it's like moving total utilitarianism up. If the same number of people live in X and Y, the critical level plays no role in that place. It just turns into standard utilitarianism. Generalized utilitarian. This is the jargon that Charlie Blackerby and I used, and we've stuck to it. Now we've got transformations. Same thing, sum over the number of people who ever live on both sides. This time it's a transformed value of utilities minus a transformed value of the critical level. Same kind of addition. If the number of people who ever live in X and Y is the same, then we get ranking according to the sum of these transformed values of utility, which we all know and love as prioritarianism. If the transformation, oh God, I don't know how to use that. If the transformation G is strictly concave. Now I got a couple of examples. First one is, present population is threatened by an asteroid doing nothing will end human existence, and a big sacrifice will prolong humanity's existence. We're going to send a rocket up and blast the thing out of orbit, or out of its present path. So I've got two alternatives, A and B. Average utility of the present generation of 100 million is 80, no future generation if we don't do anything. B is where we do something, but the present population of 100 million goes down to 40, and a future generation appears, now 100 million of them with utility levels of 50. So I just calculated the CLU values, and I get 8,000. I just used the formula population size times average utility minus alpha, and I get 100 times 80 minus alpha. For the first one is 8,000 minus 100 alpha. Second one, I've got two terms. I'm not discounting, Hillary would approve. 100 times 40 minus alpha, and so on. And then I looked and asked myself which values of alpha would make B, the path to get rid of the asteroid, better. B is better if alpha is greater than 10. If it's less than 10. If alpha is greater than 10, A is better. So alpha makes a difference. This is a whole stack of principles. As you move the critical level up, you tend to get smaller populations, and that can be written down as a theorem in every choice problem. Higher alphas mean lower populations. Now I got another example that I based on a book by Berners-Lee and Clark called The Burning Question. So here the world's nations propose a cap on fossil fuel production, which is what I favor. And there are two levels, high and low, are being considered. The trouble is that the high cap is uncertain. The consequences are uncertain. So here we have alternative P, the present course, where we have 7 billion now with utilities, average utility of 50. future generations of 5 billion with average utility of 20. That's if we don't do anything, the probable path of humanity. Alternative HS means it worked. The high cap works. Average utility of the present generation of 7 billion is 45, and so on. And then an alternative for failure, where the present generation sacrifices in the same way, but we only get 5 billion people in the future with an average utility of 20. The low cap, which is the one that's the good one, has the present generation of 7 billion with 30. They make a bigger sacrifice, and there are more people in the future, 20 billion with 35. So I figured out the values of all those things, and I assigned a probability to the two high cap outcomes. So I made it 0.5. CLU values are 450, etc. for P, one for HS and one for HF, and one for L, the low cap. Now the expected CLU for H is 465 minus 13.5 alpha. And I can get away with this because CLU has this really nifty property that you can take expected values and just run them through as if there were no uncertainty. And this does really well. It satisfies lots of axioms. Doing that, using the expected values at alpha equals 12, I find that L is the best course of action. Of course, L is probably not feasible. So in that case, we find P is better than H. And if alpha is lower, we can get it low enough so that H is better than P. Doing this using expected values satisfies Harsanyi's axioms, although Harsanyi replaced the expected utility hypothesis for individuals with what John Broome calls the Bernoulli hypothesis. I think Arrow called it that too. It asserts that actual utilities are von Neumann-Morgenstern utilities. So that's a big, big step. And it's certainly not one implied by the expected utility hypothesis. Anyway, that's what Harsanyi did. Now, I want to talk about interpersonal comparisons. The problem with all of these principles is that you need to know utilities, and utilities are very hard to compare across different kinds of households. Now, you can do it if you do things like do budget studies and so on, but you have to deal with the problem that people live in households and don't exist as independent individuals. At least not very many of them do. So here, this is my work with Krishna. If a household has characteristic Z, that's characteristics like how many there are in the household, how old they are, all that stuff. And expenditure, where is it, M? Its equivalent expenditure is the amount which would make a single adult reference household as well off as the people in the household. So that means I've picked some kind of reference single adult, like a single woman age 35, and I'm going to convert the whole economy into people like that. So here's an example. Expenditure for a household with one adult and one child is $60,000, and equivalent expenditure is $40,000. The household is equivalent in utility terms to two single adults with $40,000 each. Now notice that I don't lose the number of people in this. I'm not saying there's 1.5 people in this. Some people do. Anyway, Equivalent scales are very closely related to this idea of equivalent expenditures. In this case, the equivalent scale is, they're always equal to expenditure divided by equivalent expenditure. In this case, the equivalent scale is 1.5, and you can interpret that as saying that the two people in this household can live as cheaply as two reference adults with less money, because two can live as cheaply as 1.5. That's what equivalent scales mean. Now, when I was working with Charlie Blackerby years ago, we discovered something about all this, and that was, we investigated the case where equivalent scales depend on prices, but they don't depend on expenditure. So this, we called it equivalent scale exactness, and it means just that it doesn't depend on expenditure. But we do allow it to depend on prices. Now, in that case, we showed that we can estimate the equivalent scales and equivalent incomes from data, demand data. And Krishna took up the challenge and started to do it. Then Krishna and I extended this result, it was really Krishna's idea, to logarithmic and linear forms for equivalent expenditure. And we did estimates of equivalent expenditures for Canada. Now that means that we can make interpersonal comparisons, right? The economy has been changed into one in which everybody is a reference single adult. And so we can reverse the procedure. We can find out what their individual utilities are, and the utilities are the same. That's the way it was defined in the first place. Now, what about CLGU? Well, if we're going to be prioritarian, we need to specify this transforming function G. And it's, somebody mentioned this morning, I don't know who it was it Toby? Yes. That G is very difficult to specify. Why? Because utilities can be negative. That's when life isn't worth living. And it's very difficult to find a nice, smooth, concave function that is defined for both positive and negative numbers in the domain, and have it smooth and concave. There are a few. You can have the ones associated with constant absolute risk aversion. Minus e to the minus gamma m will do, but it's a really not very satisfactory one. So what I like is this scheme in the third bullet down. Put a higher weight on negative utilities. And that would satisfy me. You could have, of course, more notches. You could have a higher weight on negative utilities, lesser weight on utilities up to 50, and just a weight of 1 on the ones above 50. But that means you have to specify the thing, and that's not a trivial exercise.
10 minutes. Can you hear me?
Yeah.
Okay.
I got it. Okay. Now, I've got Arrhenius has criticized CLU and CLGU. Somebody mentioned Gustav this morning.
Me?
It was you. And so I've drawn an answer to him. He said, you know, some alternatives with low but positive utilities, that is, lives worth living, are ranked as worse than some alternatives with negative utilities in a smaller population. There's a way to answer Gustav on this, and I made up an example that doesn't do that. And so this one has a value function that's the same as CLU up here, above alpha. Here's alpha. Below alpha is equal to average utility minus alpha. So it's just like average utilitarianism. Going higher up here is better. And down here, it's total utility minus alpha, which is just like total utilitarianism. This doesn't have the property that Gustav objected to, but it doesn't satisfy existence independence. You have to know about Cleopatra now. Why? Because you have to know what average utility is, whether you're in this range or not. So that's how you get impossibility theorems out of this stuff. You start specifying an axiom that says you've got to avoid Gustav's criticism, and then you say existence independence has to be satisfied, and you can't do it. Okay, theoretical considerations. With Charlie Blackerby, I did some stuff on animal models of farming and research, but the interesting thing, other than writing the paper that has this stuff in it, was an example that was given to us. And this is an example about mice. Mice were used at the time, which was I think the 80s and 90s, to make monoclonal antibodies at UBC, my university. They were given cancer in their stomachs. They produced antibodies while they suffered. They could go 3 rounds. They withdrew the antibodies after each round. Or they could go 2 rounds. They were suffering. In everybody's opinion, their lives were below neutrality. They were not worth living for the mice. So, if we go 3 rounds, we need 2/3 as many mice. And that's a population question. How many mice should there be is equivalent to, given that you're going to produce a given number of monoclonal antibodies, it's equivalent to saying how many rounds should they live. And CLU, with a positive critical level, prefers the 3-round solution. We were asked this by the director of animal care. We came up with this answer. It's any positive critical level. So no matter how close it is to 0, you still get this result. And it says, do it for 3 rounds, go for fewer mice. This is an example of how bad our intuitions about population questions are. We never thought it would come out this way. By the way, they did it. Now, I only have a second or so more, but I want to say this. George Monbiot, whose name probably is pronounced some other way,
That's correct.
what was it? Says population growth is not the most important environmental issue because it's just poor people and they have small carbon footprints. But of course they're us once they come and they'll have children. Their lifetime utilities may be very low. Almost all population growth now is in very poor countries. Sub-Saharan Africa, Afghanistan, Yemen, you know. And George even says, when we allocate carbon claims, we have to do it on a per capita basis to be fair. Well, if you have more people, that means you and I get less. So it's important. Pronatalists like the Pope and many others want large populations, but they also care about future populations. I've thought about this a lot. Suppose you're a complete pronatalist. You want as many kids as possible. Well, do you care whether they appear now or in the future? Well, presumably the Pope and the other guys think the future is just fine. But that means they need a good world for them to live in, or at least a world that gets them above neutrality. And if they believe in CLU, they think it should be above the critical level. So that means, here's my conclusion, we should avoid having a world filled with people whose lives are barely worth living or worse. And that's the danger of the current trend in population growth is that we're producing more and more people whose lives are really miserable. Here's my advertisement at the end, shameless as it is. The book that came out in 2005.